Hello YouTube, this is Dazza the cameraman. Today is May the 9th, 2019, and I'm pleased to have with me again Mike Boll, and we're just looking at this question again about the moon rotation. We're using the example on April 17th, 2019, which is when Mike took some photos of the moon. So welcome along, Mike. Thank you for joining me again.
Hi, Dazza. Good to talk to you again.
Thank you. Okay, so I've got Starry Night opened here. It's April 17th, 2019, 5:23 p.m. We can see the information here for the moon. It says it rises on April 17th at 5:17, so we're a few minutes after that to bring the moon above the horizon. We can see the Sea of Crisis at the top of the moon there. And what I've done to start with is I've taken a screenshot of the moon here at this time and imported that into paint.net. And what I'm going to do to start with is to rotate the image by negative 112.6 degrees, which I think is the figure that Astronomy Live had predicted. In fact, you can see it's already rotated there because I already had the figure put in there. And we can see that the Sea of Crisis is already rotated down to this position. And if we go back to Starry Night and flick this down to when the moon sets at 5:41 a.m. on April 18th, let's hit the button there. And I've just got to bring it back a few minutes because the moon is over the horizon line at that point. And we can see that the Sea of Crisis is at this point here now, which matches pretty much what we see in paint.net when we've rotated the image by 112 degrees. You would agree with that?
I would agree with that.
Okay, so the puzzling question that we had was, because on this date, let's bring it back again, that the moon was rising, and by the way, I think I've got the moon size enlarged here at the moment. I have. The moon was rising almost due east, and we can see that the azimuth position here at the moment is 89 degrees, so we're almost looking at due east.
Mm-hmm.
And then when it sets on the other side of the sky, it's setting almost due west. So it would seem to stand to reason that if we started with the Sea of Crisis at the top of the moon, it would make sense that the Sea of Crisis would be at the bottom when the moon had crossed the sky, wouldn't it?
Yeah, and for how I understand field rotation, I would expect it to be 180 degrees. Not only from what I understand, but also that's what Astronomy Live had said. If it rises due east, sets due west, then we're looking at 180 degrees over the course of the evening.
Yep. And that would be the case, in fact, if the moon was crossing the sky directly overhead. But what's actually happening, in fact, let's turn on the local path. As I move the moon across the sky by advancing the time, it will trace a path across the sky. So I've got this set for 15-minute increments, and I'll just step this forward a couple of steps. There we go. There's the first hour. So you can see the angle that the moon is actually rising from the horizon, and you would know when you're taking photos of the moon that your telescope is actually moving to the right as the moon is rising. Correct?
I had it on a single axis mount, and I didn't pay attention. So
Okay.
But
Right. So this is tracking the motion across the sky for this particular date, April 17th, 2019. And of course, the moon's position along the horizon does change from night to night and different dates. So we can see the angle that it's rising there. And as I progress this on to when it sets, and hopefully I've still got the, yes, I've got the meridian still up there. So you can see that we're now looking at a horizontal line as it crosses the meridian at about 11:32 p.m. And we carry on as the moon has rotated over. You can see where the Sea of Crisis is now, as predicted before. So let me just bring that back a couple of minutes. Okay. So we can see the rotation there, and we can see that the moon didn't actually cross directly overhead. Let's pull that right back, and we're going to look at an all sky view here, the south at the bottom. So again, this is like we're laying on our back looking straight up at the sky, and this is the path that we would see from moonrise to moonset. And remember, I've got the moon size enlarged there. Okay, so the moon hasn't crossed the sky directly overhead, passing through the zenith. It's actually passed over to the southern part of the sky, and this has actually given us that angle up from the horizon as the moon is rising. So I'm going to do this again now, and I'm going to do something a little bit different. So let's bring that back to moonrise, and I'll just reset the local path. Otherwise I get some funny lines happening. And in our discussions, I talked to you about visualizing an aircraft flying across the sky and the nose of the plane, which direction it's pointing. Do you remember that?
Yeah.
Yep.
Yeah.
And you've explained how field rotation works quite well in one of your video demonstrations. You did quite a good job of that. So with that in mind, what I'm going to do, and let's center on that again. First of all, I'll go to the default image of the moon in Starry Night. That's what we normally see, unless I change it to the alternate image, which gives us a bit more detail. We can see the Sea of Crisis there a bit better. Now, I've been able to add, there's an option to add edit the model. So I've added a user specified image, and we've put a plane on there. Okay. And
okay.
Just reset that again and reset it, local path. So I'm going to do the same thing and step that forward 15 minutes at a time.
Okay.
And so now you can see, let's just bring that back one. Now you can see that the nose of the plane is pointing to the path that we're taking across the sky. So if we were imagining a plane flying up, it's some distance away, so it's flying up over the horizon. Obviously, the nose of the plane is going to be pointing in the direction that it's flying, correct?
Yes.
Right. So we can carry on with our plane and follow it across the sky with the nose of the plane always pointing forwards. And here comes the meridian. And once again, as we cross the meridian, we can see that the path of the plane is horizontal due to field rotation. And then as we carry on, we're now nose down because of that field rotation as we follow the plane across the sky. And this is indeed what happens in real life. If you're filming a plane flying across the sky, as I've shown in one of my video demonstrations explaining field rotation, this is exactly what we see. So there is the rotation of the plane at moonset. So we're pointing in that direction. Let's take it back to moonrise. That was the position that it took to start with. And I can add another little bit to this actually to make it a little bit easier to follow. Let's go back to the alternate model there. So we're back to the moon. So what we've been watching here is the Sea of Crisis as being our marker. So I can tag that once I get the right one to come up there.
Actually, you think it might be easier to take the sea that's to the right of it because it's more like following the green path. Yeah, like tag that guy. Or, yeah.
Yep. I will. In fact, I'll do better than that. But I'll also mark Sea of Crisis on there as well because it has been our reference point. And I will also, let's just step that forward again. I will also find the closest point to this line that I can find. You can see the third line from the top there is changing as I move my cursor around. Hopefully that'll be close enough. So I've marked that point. It's not perfectly on the line. And down here as well. Okay, so that's given us a couple of reference points, and just remember that this one is a little bit too far off to the right there. So we mark these 3 points so we can see that. So I can either play this through again, which I'm happy to do, or if we go back to our model with the plane, we've still got those 3 points marked. And as we cross the sky, we can see our points rotating. They're locked in there. They're rotating with the moon there.
Yep.
And somewhere there is the meridian. There we go. We've just crossed the meridian. Let's bring that back there. So yeah, it's just the fact that the moon is actually not passing directly overhead. If our plane was flying from east to west and passing directly overhead at 90 degrees, then it would be completely nose up. It would pass over and it would disappear over the horizon, completely 180 degrees rotated. So I think this is a good visual explanation of what we're seeing. Does that make sense to you, Mike?
Yeah, I'm trying to get my that matches what I filmed, and I'm trying to get my head around the sun or the moon rising in the east and going around to the south. So I've got a lot more thinking to do on this kind of stuff. But yeah, the animation was good, and it does match what I got. I would show you I could show you the video, but the thing is, I'm so zoomed in on the moon on the video that you can't really see. I don't know if you want that for your thing or no.
Yeah, we can do that. Just before we do that, I'll just do it with this view as well. So we're looking at the all sky view, south at the bottom there, moon enlarged, of course. And again, there is our plane flying across the sky, nose forward. This is the path that the moon is taking. And we see the same thing in that view as well. And it all makes sense that way.
Yeah. Why is the moon taking that path? That's what I can't figure out right now. But
well, you have to remember that the moon's orbit is on a tilt to the Earth as well. It's not on the same plane as the
the 5-degree
plane.
inclination. Yeah.
And just like swinging a weight around on a string above your head at a tilt, then the position of that weight as it spins around is actually going to change as it rotates around your head, if you follow what I mean.
Yeah. Okay. Well, thank you for going through the demo, and well, I'll give it some more thought.
Okay. Were you going to share your screen or?
Yeah, I'll just throw you this video on there, and that way you have it in case you need to use it. So there you go.
So you got the Sea of Crises at the top there.
Yep, same as your program showed, almost identical. And then it's just going to look the same for mine because, like I said, I had it on the single axis.
Right.
Tracker, so
that's not going to change.
No.
Now, on that point, actually, I was going to ask you, given that you're using a single axis of rotation, how does that work on a flat Earth? Because wouldn't that indicate that the moon is actually coming up from below the disk of the Earth instead of rotating around the sky?
I don't think so.
Well, if you're following on one axis of rotation, then there's certain implications that has. You obviously have to align your telescope with the polar alignment. And what does polar align mean?
Well, you align on Polaris. So Polaris is the center of the flat Earth, and it's just straight above the North Pole. Aligning on that, everything else is moving around Polaris.
Right.
So in my understanding right now, it'd just be the same result.
Okay. Well, I would imagine that if the moon was revolving around Polaris above the Earth, then it would be disappearing sort of into the northern or southern part of the sky. And you would actually have to follow it on 2 axes, not just one.
Well, I'll have to give that a little thought. I
Yeah.
don't know. I haven't thought that out.
Yeah. Maybe you could, when you were demonstrating how the two different telescopes work, the different types of mount, you were showing how how you had a single axis of rotation. Maybe you can give that some thought as to where the moon is actually going in the sky when it's over the horizon. In fact, if you keep on going, your mount is going to be pointing down below the ground, isn't it?
Well, the camera will. The mount's going to point the same way, but yeah, the camera will rotate down around the ground.
Right, and that is supposedly pointing to where the moon is at all times, correct?
If you have it aligned, yeah. So, like I said, I will have to give it some thought.
Yeah.
So there's your answer. I will
Yep.
give it some thought. Okay.
Excellent.
Now, okay, so here's the position. Let me back it up just a little bit. And so there's the position when it's set. Again, it's on the single axis, so you can't tell how it's set until we get to that building, which
Is this the same one that you started filming on April 17th?
yeah. So this is April 18th in the morning. This is the still shot that I showed when we were live with Astronomy Live.
Right.
I just took a still from this video, so it's coming.
Mm-hmm.
So there you go, and that pretty much matches. Hey Daz, do you see what's happening with the moon here?
With the compression, the squashing?
Yeah.
Yeah, because of refraction.
Yeah.
Yeah, that's pretty normal to be expected. See the same thing when the moon is rising.
Yeah, and also when the sun sets.
Yes.
I've got a nice picture of the sunset.
Mm-hmm.
So just a quick question. Since you know it happens with the sun and the moon due to refraction and hitting the thicker atmosphere, how about Mount Ruapehu?
Well, the interesting thing about that is that we can also see the scenery below Mount Ruapehu. You've got that bit of land that juts out below, but also the thing is that while we're looking at 123 miles or looking through 123 miles of atmosphere, when you're looking at the moon here, you're looking through hundreds of miles, in fact, probably even a couple of thousand miles of distance before you're actually out through the other side of the atmosphere. There's a lot more refraction going on when you're looking at the moon on the horizon than when you're looking at, say, Mount Ruapehu 123 miles away. But certainly I agree that there is refraction going on in both cases. You just don't have the same extent with
compression. Yeah, compression going on.
Yeah.
Both cases. So okay. I just wanted to clarify that wasn't a pull it out of my butt rescue device.
No.
I mean that we know that is real and compression is real. So anyway, this is off topic for this one. So you got everything you need then?
Thank you, and I hope I've answered your question with that demonstration. Are you happy with that?
Yeah, like I'll have to. I see what you're saying. I'm gonna have to get my head around some things. So
great.
That's what it's all about.
Okay, thank you, Mike.
All right, Dazzle. You have a good evening.
Thank you. Good night.
Good night.